Thank you for joining us today for the Embodied Carbon Networks 2020 webinar series. My name is Will Schrubar, and I am one of the co-chairs of the Embodied Carbon Network, along with Kate Simonin and Aaron McDade. This is the first session of a 6-part annual webinar series. So we have several exciting speakers joining us today who will be able to speak to the contractor's role in quantifying and reducing embodied carbon. You may have gotten the notification, but please note that the webinar is being recorded and will be made publicly available upon completion today. So many of you joining today are already members of the Embodied Carbon Network. I know that we do have a few guests in the audience, so if that is you, we invite you to learn more and join the network. The Embodied Carbon Network is a communications and knowledge sharing platform that was launched by the Carbon Leadership Forum back in January 2017. In terms of our mission, the ECN brings together professionals working in or with the building sector together to share news and resources, engage in discussions just like the one today, and develop educational content around embodied carbon. We're quite proud because the network has evolved into a really vibrant, engaged, and global community. To date, we're close to 2,000 professional members from across the building sector, academia, nonprofit, and government groups representing 200 cities and 33 countries across the world. We are brought together under a shared mission to eliminate embodied carbon emissions from the built environment, really in order to meet global greenhouse gas emission targets by 2050. Many of you know, but the network does comprise 9 subject-specific focus groups, which members like you can join for additional engagement around a specific topic related to embodied carbon. The ECN is funded and managed by the Carbon Leadership Forum. The Carbon Leadership Forum at the University of Washington brings together a diverse cross-section of the building industry focused on radically reducing and ultimately eliminating embodied carbon in the built environment. The Carbon Leadership Forum, or CLF, conducts research, develops resources, and convenes this network, this communications community, and incubates member-led initiatives. So thank you to our sponsors for supporting the ECN and its annual webinar series. So this webinar today will be moderated by Victoria Herrero Garcia. And again, today's webinar is the first session of a 6-part series for 2020. Each topic is based off network focus group topics. And though the network focus group chairs have really worked with their groups to identify speakers and develop the curriculum for each of these sessions. So our goal is that each session will not only be useful to live participants, but also serve as free educational resources for anyone interested in learning more. So please feel free to share webinar recordings with your colleagues, professional networks, and students. Victoria, I will hand it off to you.
Thank you, Will. Good morning, everyone. As Will was saying, this is the first webinar of this year, 2020. We have disclaimer mention of trade names or commercial products that not constitute endorsement or recommendation for use. Please note the opinions, ideas, products, or data presented by speakers in these sessions do not represent members of the Embodied Carbon Network or constitute endorsement by the network. Our goal is to introduce topics that could help participants think and talk about building industry strategies for reducing carbon emissions attributed to building materials. A few things to note before we kick off the presentations. Presentations will be followed by a 15-minute Q&A sessions. Please submit your questions through the Zoom chat function. I will track and direct them to the appropriate speakers at the end of the session. If you are an AIA member and in need of educational credits, this course is eligible for live attendees to receive credit. Please email info@carbonleadershipforum.org with your AIA number and full name, and we will report for you. Excuse me. If you missed previous webinar series from last year, all the recordings are on the Carbon Leadership website. You can access through the link is shown on the screen. Please join us also for our next webinar of this year about education, and that will be March 20 of 2020, and at the same time on Fridays at 10 a.m. Pacific time. And our next ECN quarterly call will happen in April 17 at oh, I said 10 a.m. No, 9 a.m. Pacific time, both ECN quarterly call and the webinar series. So let's move on and let me introduce you to our speakers today. Stacy Smedley, Director of Sustainability at Skanska, will be talking about laying the groundwork, defining construction-related carbon emissions. Janelle Shapiro, the Sustainability Director at Webcor, will be talking about influencing design and construction emissions. And at last, Mark Chen, Sustainability Engineer at Skanska, will talk about construction activity embodied carbon. So let's introduce you to Stacy. Stacy has a Bachelor of Arts in Architecture from the University of Washington and 15 years in the architecture and construction professions. Her resume includes the first LEED for Homes Platinum certified project in Washington State, as well as the first project in the world to be certified under Living Building version 2.0 standard. At Skanska, Stacy leads sustainable initiatives and opportunities and is considered a subject matter expert in LEED and Living Building Challenge certifications, with a passion for reducing materials toxicity and carbon emissions associated with construction. Stacy is committed to educating and engaging the AEC community on sustainable design and construction, and has served in various advisory and leadership roles, including Chair of the Washington Businesses for Climate Action, Advisory Board Member of the University of Washington Carbon Leadership Forum, Construction Focus Group Chair for the Embodied Carbon Network, Advisory Group Member for AIA Materials Working Group, and Emerging Professional Regional Chair for USGBC. She is an experienced speaker and a 2012 Living Building Challenge hero. Stacy?
Thank you, Victoria. Thanks everyone for being on the call today to hear us walk through construction-related embodied carbon, the why, what, and how. I'm going to start with just the why and the what, and leave the how largely to Janelle and Mark this morning. And just to kind of ground everyone, there's a series of slides when it comes to embodied carbon that I'm sure many of us have seen and could say in our sleep, but I always start with them because I think it's good to hear them over and over again so we don't forget. And first is just the understanding our impact when it comes to construction over the next 35 years. So these are slides from Architect 2030 that have told us that, over the next 35 years, 2 trillion square feet of construction is being built worldwide. And to put that into perspective so we can all visualize that, it's the equivalent of an entire New York City every 35 days for 35 years. And I always like to pause and just think about how many materials that equates to when you think about all
Stacey,
the things building the...
Sorry for interrupting, Stacy. I don't know if it's just me, but you're cutting off a little bit.
Okay, I will just talk a little slower and see if that helps.
Yeah, it was the reception, I think. Now sounds good. Thank you.
Okay. So if we visualize an entire New York City and think about all of the materials that have to be manufactured to build that amount of buildings, how those materials have to be transported all over the world to be put in place, and then the equipment we use to actually install those materials on a construction site, it's a daunting amount of emissions associated with all of that work. And we need to be understanding those emissions and actively reducing them because we don't have time to wait. And of course, we've all seen these slides, but I always like to talk through these also. Just the fact that we know that buildings equate to about 40% of carbon emissions globally, and that we've been under the impression that building materials and construction, the embodied carbon component, are around 11%. As we continue to dig into construction-related carbon emissions, we have found that there are overlaps with the transportation and industry categories that mean that this materials and construction component could actually be a lot more than that. It sounds like I'm still choppy, Victoria. I'm not sure what to do about that unless I try to call in on my phone versus using the computer audio.
Yeah, maybe let's try that, Stacy, because it's really cutting off a lot.
Okay, give me 2 seconds. Sorry, everyone. But
Okay,
I want you to be able to hear me. Is this better, everyone?
Yes.
Can you hear me better?
Yes.
Okay.
Thank you.
Right. Of course. I'm just going to backtrack one slide and just start with the impact again. So we know over the next 35 years, 2 trillion square feet of construction is occurring globally. And that equates to an entire New York City every 35 days for 35 years. And I always like to pause and just visualize that in my mind, because if we think about all of the materials that have to be manufactured to create a New York City every 35 days, the amount of transportation necessary to transport those materials all over the world, and then the installation of all those materials with equipment on site, it's a large and kind of unimaginable amount of emissions that we're dealing with when it comes to that much construction. And if we're not thinking about how we as contractors can influence those emissions and reduce them, we're quite frankly not being responsible. So the next slides are slides that we've also all seen, I believe, for most of us, but this is just, again, a reminder of the building sector, and it's almost 40% of the emissions pie globally when it comes to carbon emissions. And what we're finding is that by digging into this more, that this 11% we thought was associated with materials and construction emissions really is likely more than that, because it bleeds over into transportation and industry. So we're still quantifying this, and that's part of what the work that we're doing now at Skanska is all about, is really how we can start to understand this better and begin to accurately account for these emissions in our jobs. So this is my little cartoon graphic when I'm trying to explain embodied carbon to folks. First, we all, I think, are well versed in what operational carbon is, the emissions associated with building energy consumption. And that's really after a building is constructed and you turn on the light bulbs, turn on the light switch, and the mechanical systems start to work and all those things. And we've been looking at that for almost 30, 40 years now, and we've become pretty well versed on how to make buildings more efficient and build buildings with efficient systems for our clients. This embodied carbon component has really only been on people's radar screens, I think, in general, for about the past 10 years, with folks, early adopters, trying to figure this out. And really in the past, I would say 2 to 3 years, in terms of companies starting to understand what this bucket of carbon is and working to benchmark and reduce it. So embodied carbon really is the carbon emissions associated with the extraction, the manufacture, the transportation, the installation, the use, and the deconstruction waste stream of materials. So when you're a contractor and you see images of all those things, those are really all the things that contractors touch when it comes to procuring materials from manufacturers, transporting those materials to site, and installing those materials. And then for jobs that we are starting, potentially tearing down a building and getting rid of those materials and hopefully recycling them into new things. So when Skanska started looking at this, we realized that these were all the things that we could potentially inform our clients about and influence from a procurement and installation perspective. This is a slide from the World Green Building Council's report on embodied carbon, bringing embodied carbon up front. And this is really getting into the nuances of the stages of embodied carbon and how they are broken down and defined. And so what you're seeing here is first this upfront carbon, that is really where all of the embodied material carbon and construction carbon we're talking about today lives, is in this stage A. There's the product stage, which is really the manufacture of the material, really cradle to gate manufacture of the material. There's the construction process stage, which is transporting that material from the manufacturer to the construction site and installing those materials to make a building. There's then the use stage, which is really, if you think about materials and replacement. So if you have carpet tiles and you install them, you have the emissions associated with that first installation. But if you replace them in 10 years and then 30 years, there's the emissions associated with that replacement. So it's not just a one-time emissions purchase at the beginning of the job. There's ongoing additional emissions associated with those material replacements. And then stage C is the end of life stage, and that really gets into how we deconstruct buildings and demolish them with equipment. If we're doing it with wrecking balls, like in the little cartoon, or whether we're doing it responsibly, where we can reuse materials in their whole form, like a structural beam or a wood beam. If we're not doing that, how do we source separate and transport materials like demolished gypsum board, so it can be actually put back into the gypsum stream and replace raw materials. So that's really the end of life stage. And for Skanska, this is really how we look at the buildings that we're demolishing at the beginning of a project to ensure that we're kind of ending that cycle for that building that was constructed 50 years ago. Beyond that, there are supplementary stages that are kind of beyond the life cycle, as well as things like operational water use, which are really outside the scope of embodied carbon. But that's really the whole picture. The focus of our talk today is the stage A, and that's really the crux of the impact when you're looking at it from a pie perspective. It can be upwards of 80% of that whole pie. So it really is a place to start. Based on the research that we've done and folks like Architecture 2030 have completed, we also understand that this impact, this embodied carbon impact that I just showed you in that graphic is at least 50% of the global carbon footprint of buildings to 2050. So we're taking the time value of carbon, which is really zero carbon by 2050. Half of our impacts are in this embodied carbon bucket. We know how to reduce operational carbon to zero through efficient design and renewable energy. We are still figuring out how to quantify embodied carbon and then begin to reduce it. And we need to do this as quickly as possible. We can't take 30 years to do it like we did on the operational side. So how do we do that? Well, the first thing that Skanska did, and I'm going to go through this quickly, but it is important, we have to be able to talk to our clients and understand what the potential impacts are. And to do this, what a group of us did, including Oregon DEQ and the PanCat Foundation and Skanska, was fund a research grant that allowed the Carbon Leadership Forum to create a benchmarking database. So you can go to this website at the bottom of the screen, and there's a database of buildings that have done carbon footprint accounting. You can search by type of building and scope of materials. And what it gives you is this box plot that shows you, for X number of commercial buildings, there are buildings that had a kilogram of CO2 all the way up at 995 per square meter, one that had one all the way down at 10. But the crux of the buildings are in this gray area from the 80th percentile down to the 20th. So if you take that 555 kilograms of CO2 per square meter number, multiply it by your square meter, you can also do that in square foot, obviously, and look at the energy grid and your operational footprint, you're able to do something like this, which is take that data and forecast what your embodied carbon footprint and operational carbon footprint might be. This is looking at a project in Seattle where we've done this. We try to show this to all of our clients during the interview process or early in design so that they can understand the relative impacts of their carbon emissions. But for a Seattle project, it is largely embodied carbon because our grid is almost entirely hydroelectricity and our code is very efficient when it comes to the required EUI baseline. So if we're talking to a client in Seattle and we show them this pie and they've had a carbon goal on the operational side, this really starts to open their eyes to the fact that there's this whole other bucket of carbon that's actually more of their impact. We did show this slide to the Microsoft campus when we interviewed for the job, and they have lofty carbon reduction goals on the operational side to get to zero carbon. And because of being able to understand that they had this impact on the embodied carbon side of the equation, they have committed to embodied carbon reductions for their campus modernization project, and they're also going after zero carbon certification through the Living Future Institute. So I think there is a responsibility from the contractors as we are working with clients and understanding this embodied carbon component more to really share that information and help inform our clients that there are opportunities for reduction and there is a big impact to tackle. The next thing that we did was really try to figure out how contractors could interface in the design phase to help influence material choices to reduce carbon per material category. And I'm not going to go into the details of all this, but just briefly, there are life cycle tools that our design partners use early in design to look at embodied carbon impacts along other environmental impacts to make really smart system choices. But what we couldn't find was a tool that would allow design teams and contractors to begin to specify and procure based on carbon emissions of materials. So how can you look at manufacturers and actually make choices based on emissions? And really, both of these things need to happen. You have to have early design decisions happening based on carbon emissions. You need to specify and procure based on carbon to some extent, and only then can you really reduce embodied carbon and have it realized. So Skanska with the Carbon Leadership Forum and Microsoft developed a free open source tool that was looking at supply chain accountability when it comes to carbon. I'm not going to go into the details of EC3 specifically. I'm just going to do an overview since this isn't an EC3 webinar, but it is a tool that is available to not only contractors, but anyone to log in for free and actually look at carbon emissions of materials. It's something that's supported by a lot of folks in industry, and this is just a slide to show that, you know, from us, from a contractor perspective, a lot of our core clients or partners are looking at this and wanting to fund and understand embodied carbon of materials and really work together to reduce it. So it's something that's going to be coming more and more from our clients on our jobs. To do embodied carbon accounting at the material level, it's really similar to cost estimating, where we have material quantities from an estimate, and then we have a cost per unit. In the case of carbon, we have material quantities from an estimate and a kilogram of CO2 per unit that can then give us a building embodied carbon estimate. The EC3 tool, just to show folks kind of adoption and why there's a business case for this on the contracting side. It's a tool that's got over 3,000 users as of this month, and it's being used largely by architecture firms, sustainability consultants, and then contractors. So again, when we're thinking about the fact that there's this impact we need to account for, there's also the responsibility to be smart on this when it comes to our clients and our owners. Just briefly, you know, material quantities, I think for contractors typically come from estimates. So there's a way to just input information and multiply it by carbon emissions in EC3. There's also a way to import BIM models to get quantities, and then a way for our design team members to export their LCA models from software called Tally. Environmental product declarations are really key to this whole process. They're like nutrition labels for products where we have a serving size or a declared unit, and we have a kilogram of CO2 or a total carbohydrate. And this is really where we can get into the supply chain accountability that I think Janelle's going to talk about a little bit, where we can look for manufacturer-specific EPDs, ask our manufacturers to make these things, and really start to compare manufacturers based on carbon and cost. The EC3 tool currently has over 23,000 EPDs. A lot of those are concrete because concrete EPDs are mix specific. And really the whole idea here is on the embodied carbon, stage A1 through A3, which is really the manufacturing carbon, you can use EC3 to go in and assess the market for EPDs. You can start to compare suppliers and manufacturers based on their carbon and their EPD disclosure. And then at the end of the day, you could do something like this, which is what is currently being built out in EC3 to show overall building reductions based on the supply chain, what was possible, what you achieved based on environmental product declarations for products, and that can be broken down per material category to really understand where reductions are happening and what's been realized. And really just at the end of the day, the whole point is to really reduce supply chain emissions and have our role as contractors inform that through working with our suppliers, asking for disclosure on carbon, and then helping our owners specify and procure with carbon emissions in mind, just like cost. If we do that, the end of the day, all of the emissions for all these materials go down because suppliers start to understand that we are being assessed, they're being assessed on this, and they actually need to reduce their emissions to compete. And just one little note on the stuff that Mark's going to talk about on the construction site side. There's still a lot of work that needs to happen when it comes to what happens and how we account for emissions once those products leave their manufacturing facility and get to site. There's a lot of research happening around this, and you're going to see how Skanska is approaching tracking it from Mark's presentation. But really, innovation needs to happen on the construction site side, and we need to be accounting for those emissions and really pushing our equipment partners to be thinking about how we can electrify things and reduce emissions. This is just an example of how there's a site in Europe where Volvo has gone to autonomous vehicles that are 100% electric, so really a zero emissions quarry. So these things exist, but we need to be the ones pushing them and helping our suppliers and manufacturers and equipment partners understand that this is coming. The last thing is just the fact that there's policy about this. So it's not just us at certain construction companies that are doing this because we see the potential need for reductions from a climate perspective. There's also clients that are looking at this from a LEED certification perspective, where there are points in the certification system for embodied carbon reductions. There's a living building challenge now with zero carbon certification and clients like Microsoft and Amazon committing to those programs. And then there is policy work that's happening that's looking at how we look at embodied carbon just like we look at energy use. This is just showing kind of where these things have been adopted so far. There's policy implemented in California for certain material categories to reduce emissions via EPD reporting. There's a low carbon concrete code in Marin County that you can go look at and research. And there's also draft codes and policies coming at all sorts of different places. So this really is something that's going to be coming from owners. It's going to be coming from policy, and we need to be smart as contractors in how to meet these requirements and do our part. Just examples of the fact that you can go download these codes and read them. And with that, I'm going to hand it over to Janelle to really dig into how WebCore has been looking at this from a contractor perspective. If you have questions on EC3, you can go to the website and register for free for the tool and review some of the resources there. And if you have any questions on embodied carbon in general, you can feel free to email me. Also, I am the chair of the ECN construction group. If you have questions about how to join that, you can reach out to the Carbon Leadership Forum and the ECN, or just feel free to email me directly.
Thank you very much, Stacy. And now we are going to introduce Janelle Shapiro. She is the Sustainability Director at WebCore. Janelle leads and develops all international and external sustainability efforts for WebCore builders. She is WebCore's sustainability expert and leads all efforts on matters related to sustainable design and construction. Her primary responsibility is providing green building services to WebCore's clients and AEC community, sustainability-related pre-construction services, and implementing WebCore's corporate ESG program. She oversees the team collaboration from pre-construction through construction of credit documentation management and submission to ensure that all WebCore projects meet or exceed their intended sustainability goals. She carries extensive experience in embodied carbon footprint reporting of construction materials and executing deep green integration among stakeholders from project inception through building operations. In addition, Janelle develops and manages all corporate initiatives aimed at increasing employee community involvement and Webcore's corporate social responsibility goals. Janelle?
Hi, good morning, everybody. Can you hear me?
Yes, sorry.
Okay, fantastic, no problem. Good morning. So yeah, as Victoria mentioned, my name is Janelle Shapiro. I oversee sustainability for Webcore Builders. We're a general contractor, mainly doing work in California. And I'm excited today to talk to you a little bit about how we engage in the design and construction phases to reduce our embodied carbon impacts. So no pun intended, but kind of this picture responds to this saying right here, laying the groundwork. So I want to start with identifying where we started and where we are today. So as Stacy kind of mentioned, the impact that our emissions in which we influence at the time of material procurement are Scope 3 emissions. This includes things like purchased goods and services and materials. These are all the upstream cradle to gate items, and those are the things I'm going to talk about today. So in order to track this data, I want to walk through our process from inception and where we are. So Webcore got involved with EC3 and the Carbon Leadership Forum around April of last year, so it's nearly been 12 months. And we really were asked to support the development of the tool from another GC's perspective. Skanska had obviously been a partner and an initiator of the tool from inception, and we wanted to come in as a collaborator and not a competitor to Skanska, really act as the other GC perspective, or the way that we do our estimating efforts and our costs is a little different than Skanska. And so we were able to bring a different lens to the development of the software tool. So between April and November, when the launch of the tool began, we really were diving into the work with the IT team and the developers on what we could improve. And what we found was that it's actually, funny enough, not a challenge to sell to executives. If you guys on the call may be responsible for sustainability within your own organization, sometimes it's an uphill battle, but we're pleased to know or find out that our executives had already been thinking about this. They'd been hearing about embodied carbon from their clients. They wanted to take this as a priority. They saw the value in it and knew it was really where the industry was moving towards. And the executives also decided that climate change needed to be more of a focus moving forward. So it didn't become a challenge necessarily for us. It was easy to integrate implementation within EC3, which is fantastic for us. And they also challenged us and wanted us to determine our impact across our entire portfolio. Again, we do business all up and down California, so a lot of jobs, and how could we find data that you see here in this table and start to quantify our emissions. This is information that we would need to understand our Scope 3 impact. So we really set off to find out. So once we mastered the tool, and I don't mean mastering EC3 in the relative term, you know, there's always things to learn with that tool. There's always new changes daily, but we really decided that we wanted to take it to the next level. And there was much more that this insight of EC3 allowed us to do. So how could we take it to the next level and go beyond just data entry and reporting into a software tool? So we started asking some questions internally about what new norms could we directly influence as a general contractor? What were the local jurisdictions doing that we could build upon? Again, doing business in California is fantastic, given local codes are quite stringent compared to other areas in the States. But how can we build upon that and move that even further along? And then also what needed more focus within our industry. We felt that general contractors typically kind of were left out of embodied carbon conversations, and we wanted to make sure that we can embed ourselves more systematically into this process. So what we ended up coming up with was our carbon commitment. And there's 4 items here, and I want to go through that. So the first is, the first part of our commitment is to employ EC3 in all new projects, ultimately with the goal of comparing and reducing embodied carbon emissions from construction materials by making informed material selection. So we really wanted to make sure that we could utilize and continue to help support the tool that we spent months helping to develop, The second was requesting and collecting data on all, for all concrete, structural steel, rebar, drywall, and glass manufacturers in order to request and collect EPDs at time of bid for review as part of our evaluation project process. We'll go into this a little bit more on a future slide. The third item is just continue as a pilot partner for EC3 to continue to give and provide valuable industry experience and expertise as we start to actually use the tool. There's always a loop that needs to come back to build that back into the system to continuously improve. And then finally, go beyond the public project requirements set forth by the Buy Clean California Act. So something that Stacey quickly mentioned in its last of her slides, but this act establishes allowable GWP limits for certain material types. And so beginning of next year, we want to start collecting, through this year, we want to start collecting historic data for all the items 1, 2, 3 that you see listed here. And then eventually, beginning of next year, start setting and figuring out if there's more stringent targets where applicable that we can take and go beyond the California measures and requirements. So this ultimately became our commitment and really our guiding light as to what we now are doing as it relates to embodied carbon and evaluation. So ultimately, obviously, the next step is implementation. How do we make that a reality? And really the first thing is building a critical team. So in order to integrate embodied carbon evaluation during our design and construction process, we really felt that we needed to create a critical team of experts, as you see here. The first being the executives, already mentioned, they were on board. We wanted to make sure we had continued transparency and communication back to them as to how progress is going. The sustainability department, so that is myself and a couple others in-house. We act as in-house specialists as within the GC and really helping to drive this program to full inception and success. The self-perform groups, so we do self-perform concrete, drywall, and interiors. And concrete and drywall specifically are some of the two biggest drivers of emissions. And so we really wanted to make sure that they were part of this story and this conversation as well, that we could use their knowledge and build upon their relationships to drive success. And then the fourth piece is the design partners. So it's critical that we really get the structural engineers and architects in the room and get them engaged as design is occurring before our scope of influence is too late. And many times as a general contractor, we get invited to the party a little bit too late where we don't have any influence. And so we wanted to make sure that we keep these conversations open and frequent early on. And then finally, our clients. So we're beginning to prioritize clients that want to listen and that make it a part of their story too. They can tell their embodied carbon story through us and through collaboration with all of these individuals you see here. So the next thing we did was this road mapping exercise. We developed a roadmap similar to this for concrete, rebar, and drywall. Basically what it is it's a workflow to identify what steps of design and construction there were decisions or actions to influence EPD and embodied carbon evaluation. So we found that during spec design, it was something we had to start paying attention to during solicitation of bids, during buyout of our subcontractors, and then ultimately during procurement of the materials. These steps are all built into each of the roadmaps we developed and were critical to really set the path for success. And this has become our new process in order to track Scope 3 emissions for our entire portfolio. And we use these within our self-perform groups and within our estimating teams to make sure that we're progressing at the rate that we expect to. And then another element within the workflow that needed to be changed was our bid buyout process. So we developed these EPD request forms for the following materials. So for carpet and ceiling tile, concrete, rebar, drywall, framing insulation, enclosure and glazing, structural steel, metal stairs, and timber. So for all those material types, we developed a form very similar to this, an EPD request form. And really, there's two components of this form that we wanted to address. I think the first one being that we wanted these forms to teach the bidding subs the value and importance of embodied carbon and really prioritize it as part of our evaluation process with the bids. this ultimately gave more transparency, right, to those who didn't know what the three-letter acronym EPD meant before this point. And I'm sure many of you guys on this call realize that maybe today's your first time learning about an EPD, maybe you've heard it a million times, but a lot of people that we work with on a day-to-day basis don't know what that means. It's new to them. So we need to start teaching and educating them. And so we felt like this was a valuable opportunity to do so. And then the second component was really to be sure that we collected accurate data that could be easily transcribed into EC3 for final evaluation. If you have inputted quantities into the tool, you are very familiar that sometimes collecting this information can be more difficult than it really should be. And so it's really important to just find the info from the right resource. And that typically is the challenge. So these forms help us collect the data at point of source, and the transfer of knowledge and transfer of data into the tool is much more streamlined in that manner. And then the third piece of the item within the current concrete workflow that needed to be changed was this bid evaluation process. So currently our concrete bids from our suppliers are prioritized based on cost, schedule, and design. That's typical in construction. You always will hear cost and schedule is key, right? But what we thought that in order for us to make informed decisions, we really need to and meet our carbon commitment, we needed total GWP information as well as a factor. So we added in total kilogram CO2 equivalents for as a data point to collect from each sub, and we compared that against cost. So we updated these leveling sheets to be sure that GWP levels were compared from sub to sub. And now it's really fantastic because it's become an evaluation tool and metric for our self-performed concrete teams to take into effect when they're reviewing bids. And it makes them more educated and more knowledgeable about this language and this process as well. And then the last part is a drywall group. So as mentioned, our self-performed concrete and drywall team members were key in making this successful. And so our workflow for drywall also needs to be changed. But what we discovered kind of through this evaluation and further talks with our team members was that it was more difficult to integrate EPDs into their buyout process compared to concrete, mainly because they don't buy out their own materials. They use purchasers, and these purchasers, these individuals are the individuals who actually make the decisions. Our team members don't make those decisions. So we had an additional step in the process that we need to figure out. And so what we did was we determined as a team that we needed to start influencing certain product manufacturers based on our consumption of that material type. So identifying what products or manufacturers still align with our carbon commitment, yet would not jeopardize traditional design and construction means and methods, I think was really important. So we started talking and educating manufacturers on things that could help support our use of their products during construction, and ultimately our priorities were the lowest GWP values. But what we did end up finding out was, there's a popular product, USG EcoSmart, and in talking to our team and our service providers, that this actually was not a favorable product for our laborers. It may be a product that's spec'd or that architecture community likes because it has high recycled content, has low GWP, but ultimately this wallboard actually tends to crumble when cut, and in a lot of cases, this is due to the high recycled content, and it results in a lack of productivity and lost material and waste, right? So these conversations are still preliminary. These are just some of the early discussions that we've been having with some of the manufacturers as well as with our team, and really illuminating ourselves. And it's not as simple as saying, go find the lowest embodied carbon product out there. We have to make sure that it's a collaborative effort and that all team members are talking and understand what the value of that is. And another piece of this that we found was, and Stacy went on or talked about it just a little bit, was that we found that the drywall manufacturers don't actually produce that many EPDs right now. Concrete is the highest performing EPD producing industry. Drywall is, I don't even know what percent, very, very small percentage of the total EPDs that are out there. And so we're working with these manufacturers and starting to request more frequently production of these EPDs and hopes to change the trend in the future. So more to come in the future on that. So I now want to go into two different unique case studies where we began to implement these items that we had just discussed and show kind of how we've been applying this new knowledge and power and process in our new business operations. So the first project here is a 960 West 7th Street in Los Angeles. It's a 56-story, almost 1.5 million square foot mixed-use apartment tower in LA. This project really prioritized early coordination with the ready mix supplier, who was national, as well as the structural engineer team, who was MKA, and ourselves as a GC, and our self-perform group, Webcore Concrete. So the team's goal early on, and the need for the design, was to increase compressive strength. But in order to do this most effectively, they had evaluated two different mix design options. So the first option was a kind of a weaker option. So it was utilizing a local aggregate, and for whatever reason, these options, or this aggregate in the local LA market, are weaker, and ultimately that they therefore would require more cement to be added. And as we know, cement has a higher GWP, increasing the total embodied carbon. So our team needed to coordinate with the suppliers to see what strength opportunities or properties that we had to meet based on the design, what we could meet with the local aggregates, and then basically assess the cost benefit analysis as to what were the benefits and the cost impact, and how would this align with our structural design, and can it be achieved with the local aggregate. So they did that one you see here in the table is considered the gray lines. That's the old aggregate choice. And so what they decided, let's look elsewhere, let's see what else is out there. And the alternative option was using this Orca rock aggregate from British Columbia, which ultimately would be barged down versus the local rock would be local and trucked to the site. So it ultimately ended up being a superior aggregate, a more dense and stronger rock, to help achieve higher concrete strength that was needed for the design. And it also achieved better performance for modulus elasticity, which is necessary to help the building's performance with the seismic swaying that we have here in California for earthquake safety, and then also long-term deflection of the floors. So this was a design need that ultimately the team decided was priority. But the team also understood that this meant that it was going to be a non-native aggregate, and that it would have to be barged in at a much further transportation cost and distance than the local one. So the team really saw this as an opportunity to take into consideration the full impact of embodied carbon and do this assessment. So what you see here in this table is the evaluation through the EC3 tool, and ultimately the old versus the new being the Orca, saved about 11.5 million total kilogram CO2 equivalent. So it was a huge saving by making the switch, even taking into account the location of the aggregate and needing to barge it to the site. So ultimately, for multiple factors, not just more than just embodied carbon, but also strength and deflection reasons, the team decided that the Orca was the right way to go. So this is an interesting process that the team managed to implement as well as assess. And in talking with our Webcore Concrete team, a couple of challenges that I found were, cost drivers, decisions due to competition was just huge. So cost is always key. The business and the marketplace is really challenging right now. And if there's always ways for us to find open and frequent dialogue and making these discussions a priority, it's really key to do early and often. And then the final case study is this Northern California job. So this client came to us wanting to evaluate schedule and cost of two unique core systems. So the first was a reinforced concrete wall system, typical construction, and the other was a composite steel plate wall filled with concrete. This was actually an MKA invented type of construction that you see on the right. And so they wanted us to ultimately say what was the schedule and cost impact. So we decided to also embed embodied carbon into the analysis with our estimating team. It wasn't something that they had prioritized as clients, but we wanted to make it part of their discovery. And ultimately, the alternative design option actually ended up saving about almost 13 million kilogram CO2 equivalents, but it wasn't an item that was deemed critical to the client. And the reason why I'm telling you guys this story is because, as already mentioned, I think it's really important for us to be transparent and communicate the options that clients may have, even if they don't ask about it. And even if ultimately it's not a decision factor that the team decides to make an impact on. So this was not a driver for the client, but it was something that we felt was valuable to show them anyways. And then I think finally, next steps for really all of us is to think about in the AEC community is how can we improve this process moving forward, test it out on more projects, have a continuous innovation loop of redirecting and changing and editing the process as needed as the marketplace becomes more familiar, really begin to evaluate our Scope 3 emissions over time through our historic data collection, and finally collaborating with other AEC manufacturer leaders. It takes a village to make this happen, and the opportunities really are endless. And I think I'm excited for everybody on this call to really hear what we have to say today, because I think it takes many people more than just the general contractors to make this successful, and I look forward to the future. So thank you guys very much, appreciate it.
Thank you, Janelle. Now we're gonna introduce Mark Chen. Mark is a sustainability engineer with Skanska, USA building in Seattle. In his current role, Mark oversees Skanska's project-specific construction site carbon, water and waste accounting and reductions measures, embodied carbon efforts, healthy materials research, and green building certification project delivery. Prior to Skanska, Mark spent 3 years as an estimator and project engineer with Turner Construction and holds a bachelor's degree in civil engineering from the University of Washington. Mark?
Thanks, Victoria. Sorry, I realized I was on mute, so I had to go back in and unmute myself. But
it's all good. We can hear
you. So I will try and power through this as fast as I can. But yeah, I'll be talking about how we at Skanska have been tracking our carbon emissions on our job sites, specific to our construction activities. So I'm sure, just like this guy in the picture, a lot of us have been on a construction site before and thought, wow, there's a lot of stuff going on here. I wonder how we can start to account for the carbon emissions specific to our project sites. So I'm just going to go through our process and methodology of how we've been doing it on a project here in the greater Seattle area with a client who was really interested in this and really pushed for us to develop a methodology behind it. And so before I get into that, Stacy and Janelle kind of touched on it earlier, like where this falls in the overall embodied carbon lifecycle assessment stage. So when we're talking about embodied carbon, a lot of the times we're looking at EPDs and EC3 or whatever other tools are out there, and we're getting, carbon emissions per declared unit. And usually that only covers your product stage, A1 through A3, your raw material extraction through your manufacturing. And so what we're trying to fill a gap on is this part of it, your A4 and A5 stages during your construction process. And so that's your transport to the job site, and then ultimately on the construction site, your emissions associated with your installation of the product or material. And so just to lay the groundwork, really boiled down to, for us, tracking 4 different things, and that was material transport to site, waste hauling from site, any off-road equipment and vehicles, burning fuel within our project fencing, and then our temporary power usage. And so in order to do our calculations and to actually get a carbon footprint from our construction operations, we really were just pulling 3 main things on this slide, 2 of which come from an EPA greenhouse gas inventory document that I've included at the bottom if you want to check it out. But really what it came down to was, if we can get a total fuel burn or a vehicle mile traveled and a kilowatt hour consumed on our site, we could pretty easily get to a carbon footprint. So from that, knowing that we needed to get fuel burn in gallons or vehicle miles traveled and kilowatt hours, we asked ourselves and working with our project team, what are we tracking and what are our trade partners and subcontractors already tracking that we can piggyback off of to make this, as time efficient and painless as possible. Because obviously, like we've talked about before, time and cost impacts are always at the forefront of a contractor's mind. And so we were kind of brainstorming how to streamline this whole process. And so what that, materialized into were a couple just simple submittals every month that we asked ourselves and our trade partners to fill out. So to cover transport to site, that submittal sheet looks something like this. It was really utilizing, again, trying to leverage the data that we already had access to. So for our specific project site, we had a delivery schedule that our superintendents and project teams were managing that gave us visibility to all of the deliveries coming on site. So it was really as simple as me pulling from that spreadsheet, sending it to our trades, and having them fill out all of the information to the right of the box for round trip distance to site, type of vehicle, etc. And then for installation, that's mainly all of our off-road equipment fuel burn on our project site. It was the same exercise. We asked for a number of different things and data points from our subcontractors and trades. And what we found out is that a lot of this is already being tracked internally by those firms. Usually someone out there has an equipment log or at least a fuel log that gives us access to the data that we need. And ultimately, actually one of our trades pushed back a little bit and said, this is a little too much of a lift to fill out all this data. So we just simply asked for the fuel invoices that they had been receiving on a monthly basis, which was a pretty simple exercise. And so it's the same concept for waste haul tracking. We get diversion ports on a monthly basis that, gives us access to where we're hauling all of our waste hauls. And so just knowing the vehicle mileage behind that is really all we needed to get a carbon footprint. And same concept for temporary power. I think it worked out well in this project that we, the general contractor, were paying for our temporary power usage. So this was as simple as me talking to our accounting team and having them show me how to actually go into the system and just pull our monthly utility invoices that we're getting billed to the job site. And every utility invoice shows a kilowatt hour usage based on a meter reading for a given period of time. And so with that and our utility emissions factor, it was a pretty simple calculation to do. And so once we had all of that information, Microsoft Excel being the powerful tool that it is, we were able to automate a spreadsheet that basically spat out all of this information, and that allowed us to kind of digest all of the data that we were getting. So one of the big things, and this is just an example of kind of how our reporting sheet looks. So what that gives us is on a monthly basis, obviously a carbon footprint for the month. But once you start kind of diving deeper into it, it gives you some really useful information, like what is contributing the most to that carbon footprint. And so in this particular hypothetical case, our off-road equipment's obviously contributing the most out of our total CO2 footprint. So, if we want the best bang for our buck, as far as trying to figure out ways to reduce that number, we're going to target our off-road equipment, maybe not so much on the side of temporary power. It also allows us to break it down by trade and source of, where the carbon emissions on our site coming from in proportion. And then the other, metrics we've been tracking, trying to normalize all this carbon data against some of our actual, work in place, if you want to call it that. So like for our demolition subcontractor, if we know that, our demolition subcontractor is emitting a certain amount of carbon per month, and if we know that they've been performing and demolishing a certain square footage of building, we can start to look at that on a pounds of CO2 per square foot of structural demolition. So we've been looking at that for that metric for carbon emitted per cubic yard or truck cubic yard of excavation that we've been hauling off site. And same thing actually for water usage too. And that's a whole nother conversation, but been a really interesting other data point to be tracking. And so this ultimately rolls up into a project total spreadsheet. And that's kind of how we've been tallying our numbers and actually accounting for our carbon on site. And so going to our reduction strategies, I showed some of those submittal sheets at the beginning. And so this is just a snapshot of a hypothetical one that we've gotten back from a subcontractor, this one for drilling. And having the data actually allows us to ask the right questions and to say, hey, drilling subcontractor, you're renting some pretty old pieces of equipment that are probably not very fuel efficient, and you're using a lot of fuel. Like, can we have a conversation, talk with your leasing or renting agency, and start to see what the possibilities are for getting newer equipment on site. There's other reduction strategies that we've looked at around just reducing fuel burn. And so Stacy was more involved with this a long time ago. On one of our projects, we had a bunch of reinforced concrete buildings that were being demolished, and thinking about it, instead of demolishing that concrete, trucking it offsite to eventually be crushed down into base course and then trucked somewhere else to be used as road base. We worked with our demolition subcontractor to get a concrete crusher on site and to actually use this crushed concrete for applications on site as road base for our construction haul roads. And so Stacy did a lot of calculations around that on the carbon savings associated. And so I think that was kind of a big win for us, just on the reduction side. There's also a lot of alternative fuels out there. Some of you may be familiar, biodiesel and renewable diesel. I think in California, renewable diesel might be a little more familiar and something that is supposed to be drop-in ready with any diesel-powered engine. And so, we can start to look at, going back to that emissions factor of diesel, that 22.51, pounds of CO2 per gallon burned. Finding fuels that have a lower number and lower emissions factor behind that. And so here's just a snapshot of some information I've found. And like a lot of things, sourcing is a very important thing to consider. So, if you have renewable diesel that's being sourced from like waste cooking oil or tallow, that's great. If it's coming from palm oil or soybean oil that's contributing to mass deforestation in Southeast Asia, maybe try and stay away from that option. But just another thing that we're looking at and researching to try and drive reductions in our emissions. And then finally, Stacy talked about this too at the beginning, some of this research that Skanska over in Sweden is doing with Volvo on electrifying construction equipment. And so, I haven't seen a whole lot of this make its way over to the US, but it's kind of a glimpse of what's on the horizon, hopefully the direction that the industry is going in. And that was it. If you have any questions, feel free to reach out via email, but this has been a real work in progress, and it's really just us taking our best stab at it. So if anyone has comments or ways that they think this process could be improved, it would be all ears.
Thank you, Mark. And now we are going to jump into Q&A. So please use the Zoom chat to send your questions in. I see that there's some questions already here. And I am gonna go with a question for Janelle. And well, I'm mixing up a little bit of the questions. So at what stage of design were you brought in for the case study that you presented, the 960 West 7th project? And also, how was the coordination with the structural engineer? And from your learning from that process, when do you think the benchmark for the for the bidding process and all these things that you work with every project, when should it happen? It should happen in a schematic design. It should happen in design development.
Yeah, so great question. I don't know the exact time in which we were brought in for 960 West 7th. I know that we're acting as a general contractor for that project, as well as we have our self-perform WebCore concrete team. So just by means of doing self-perform for these large-scale jobs, we can at least communicate early and more frequently with the concrete team when it's necessary. And the other value that we had on that job was MKA is a structural engineer, and they're hugely involved with EC3. Don Davies is one of the founders of the EC3 tool with Skanska. And so we have always had an open dialogue with them on making this a priority and finding the right projects to have the early conversations with. So I think it was a matter of us being the right team and making that conversation active as early as possible. The other part of your question, Victoria,
was there any coordination with the structural engineer? And from your learning from this process, and when would you say that the benchmarking should happen?
Yeah, so definitely early coordination with the structural engineer and also our ready-mix supplier. So one of the challenges, and I kind of quickly skimmed over it, but one of the challenges I discussed regarding just concrete in general is that the design comes too late, the engineer needs to get design drawings out, or we need to get bids from our suppliers on what mixes they might be using. This whole process kind of is backwards thinking, and our structural engineers are just using typical mixes. They may not be using ones that the ready mix suppliers can actually readily provide. They're on site in that locale, as I mentioned. So that whole process is really convoluted, and I think by just having these talks more frequent and more transparent, I'm hoping that in the future it become a little bit more of the norm. But right now, my understanding of the way that it works is it's not norm. In regards to when, SD versus DD versus CD, the process that we're taking is we find jobs that it makes sense at the SD phase, because that's when we get the first bid request for our concrete team. So if we don't initiate it then and we don't start asking for EPDs right at that point, then we may have missed the mark. Whereas we might get other jobs where we're pulled in a little bit later and GDs are nearly complete. So we start the process then. So I wouldn't say that's necessarily an ideal or critical time. It's just a matter of sooner the better, I guess. Does that answer the question?
Thank you, Janelle. Yeah, sooner the better. There's a question for all, but I'm going to address it right now to Stacy. So how would you, you are all in the contractor or the GC side, but how would you recommend to introduce these embodied carbon talks to clients or GCs that they are in states that they don't really talk about it as much as California, Washington, or other states? And how do you introduce how much does it cost to reduce embodied carbon? Like, how do you start that conversation?
Well, I've been in the sustainability sphere as an architect and contractor now for almost 20 years. And it's the first time there's something where we found, based on actually implementing the request for EPDs and tracking the carbon emissions, almost upwards of 30% reduction in carbon emissions, just based on the available supply chain at no cost. So what this means is that if in places where there isn't data yet, the first step is doing what Janelle very eloquently talked through, is requesting the EPDs and helping suppliers understand that folks are starting to ask for them, and that they're not a $1 million investment. They're a pretty low investment in terms of cost. And once you have them, you have them. So it's getting more EPDs generated, which is not a cost to us. It's just a conversation and a kind of process that we have to put into place. Once the EPDs are there, the conversation moves to that. We have 3 products that meet your criteria, and the assessment where you can do what Janelle showed, where you have kilograms of CO2 per unit of material and kilograms of CO2 or cost per unit of material, allows just information to be there. And in many cases, the low carbon option is also potentially the low cost option. So I don't think it's going full force and saying, hey, we have to do this now and here's the low carbon option, you have to use it. It's really just about getting the data and disclosing it and allowing that to inform choices, so that if there is a win when it comes to emission reduction and cost, it can be taken. And there's, again, like I said, more owners and more places that are starting to look at zero carbon policy and include embodied carbon in that. So it won't happen in every market at the same pace. There's going to be markets that lead, that then have the examples that can be used to show that this is possible without a cost impact. At least this low-hanging fruit, 30% reduction. If we all do that, then that's actually doing something pretty good in this first kind of 5 to 10 year range.
Thank you, Stacy. Mark, there's a question for you. How is your A4 transport greenhouse gas emission comparing to your A5 construction emissions?
Yeah, so I was actually about to respond on the forum, but so on the specific project that I was referencing, it's been, I guess, pretty close between A4 and A5, but I just want to highlight that this project that I am talking about is a pretty unique one, just in the size of it and the overall scope. So I don't know if that would necessarily be indicative of a lot of other projects, but yeah, probably I would say around 60-40, A4, A5, somewhere in that ballpark.
And then I guess just to add on to that, if you're looking at the kind of A1 to A3 versus A4 to A5, so what is the comparative impact of the upfront embodied carbon of manufacture to gate, and then construction impacts? The construction impacts can be somewhere in the 3 to 5% of the total range on a typical project in terms of our accounting for this over the past 5 or plus years at Skanska. But there's also the mindset that those are our scope 1 and 2 emissions. And really, those are the ones that we have to account for carbon disclosure project and other things. So we need to be looking at all three scopes. Janelle was talking about how the embodied carbon of the manufacturing components are scope 3 as a contractor. And so helping to inform that really informs our clients' CDP reporting, but our scope 3, our scope 1 and 2 are what we're personally responsible for as a company, because we can control them more, more directly, and we need to be reducing them too, because what's going to happen when we get low carbon materials, and then all of a sudden what we haven't accounted for are the emissions associated with transport and installation. So even if it's only 3 to 5% of the total, it's still an important 3 to 5% to address.
And I would say, just to piggyback on that, it feels a little bit hypocritical if we're asking our manufacturers to lower our scope 3 emissions, but us ourselves aren't really looking at it and how we can reduce our scope 1 and 2 emissions. So yeah, just to support what Stacy's saying.
Thank you, Stacy and Mark. And we're right on time right now, but since we went a little bit over, I have the last question, and this will be for all of you on the general contractor side. Like, how are you implementing this? It's like a 2-3 questions. Are you implementing this in every project right now? How hard is to educate bidders, like to provide this information? And have you seen a decrease or increase in cost when you're doing this process?
I guess I'll start with Janelle. We are ultimately plan to implement it on all projects. It's a slow moving boat, just in the sense of the longevity of our jobs and the ones that we can get in the door at the right time within our pre-construction department. So yes, ultimately we are, but right now we're doing it on a good handful of projects. In regards to educating our bidders, so you saw the process that we're going through and the new forms that we've developed and the new processes that we are now managing within our teams. But that too is a learning process. So right now, us requesting EPDs from XYZ manufacturer, maybe be responded very positively, where it may not be responded very well in another manner, just because they don't even know what that acronym means and they don't understand the concept of it. So again, I think the more education that all of us collectively provide to manufacturers, bidders, subcontractors, et cetera, the more normal this will become over time. And right now, it's just an uphill battle a little bit. We know some of the suppliers that are always going to give us the right information, and we know the ones that aren't. So it's just moving the needle slowly but surely.
Thank you, Janelle. Stacy or Mark, anything else to add, or we just jump into the end?
I guess for, yeah, oh, sorry, Stacy, go for it.
I was just going to say, I think Janelle covered it. So Mark, please do add more.
Yeah, I guess just specific to my content with the construction activity emissions accounting, you know, for the most part, because we've been trying to, you know, like I was touching on, leverage the data that we're already tracking, it really hasn't been a cost issue so far. A lot of our trades are reporting that it takes them anywhere between 1 to 3 hours per month to fill out our submittals. So it really hasn't been a huge lift for most. I'm hoping it stays that way.
Thank you very much, Mark. And this concludes, I just noted, our 2019 webinar series, 2020 webinar series. I really want to thank Stacy and Janelle and Mark for joining us today and sharing their knowledge with us. And thank you for joining, everyone. And if you have any questions or comments, please send them to info@embodiedcarbonnetwork.org. And if you have not joined the Embodied Carbon Network yet, you can sign up today at embodiedcarbonnetwork.org. Thank you very much and have a wonderful day.